Hello, welcome to this lesson of our study of partial differentiation. Okay, so if you have not subscribed to the channel, kindly subscribe, okay, so that you can support the channel as well. All right, so today we'll just go through implicit partial derivatives. Okay, so the first question is find dy dx if y squared minus x squared minus sine xy equals 0. Okay, so here you can actually use an idea in partial derivative to find dy dx, where after everything we make dy dx the subject. Okay, but what you will use here in partial derivatives is that we just use this formula, that we assume that the whole of this function, okay, so we make sure that everything at the right side of the equation is equal to 0. I mean, this is equal to 0, so we are okay. Then we call this whole function at the left side. We write a function of that. Okay, so it's in two variables, x and y, so we let f of xy be equal to y squared minus f squared minus sine xy. Okay, now to find dy dx is very simple. Dy dx will now be equal to minus fx. I hope you understand fx, and over fy. Okay, so this is very simple. So from our f of xy, all that we need to do is to find our fx. So f of xy is equal to y squared minus s squared minus sine of xy. Okay, now this fx is simply differentiating the whole of this function with respect to x. Okay, so fx will be equal to minus 2x, okay, minus y cos xy, because when you differentiate sine you get cos, but before that you have to differentiate whatever that is here with respect to x, and when you differentiate xy with respect to x you get y. Okay, so it becomes y times the derivative of sine, and that is cos of xy. Okay, I hope you get this. And fy will be equal to 2y minus s cos of xy. I hope this ones you understand. Okay, then very simple like that, our dy dx would then be equal to negative of fx, okay, over fy, and that is equal to negative of minus 2x, okay, minus y cos xy all over 2y minus s cos xy. So you can go ahead and multiply the negative here through the numerator. Okay, and this will give us a final answer of 2x plus y cos xy all over 2y minus s cos xy. So that is very simple like that. Okay, all right, let's continue. Now find del z del x and del z del y for a function that is of this form. Okay, so the function is s squared sine of the expression 2y minus 5z equals 1 plus y cos 6z. Okay, this is very simple, but then it's somehow tedious as well. Okay, so before you solve this, know that this is implicit. It's just an equation. Okay, so what you have to do is, first of all, we make sure that the right side of the equation is what, 0. Okay, so we have to put everything at the left side of the equation. So s squared sine of 2y minus 5z minus y cos 6z, okay, minus 1 is equal to 0. Okay, I hope this is okay. Now we'll let our f of here is 3 variables. Okay, f of x, y, z be equal to whatever that is at the left side of the equation. So s squared sine of 2y minus 5z minus y cos 6z minus 1. Now del the same thing, so del z del x will be equal to minus fx over fz. So obviously you know that del z del y will be equal to minus fy over fz. Okay, so we know that f of xyz is given by this. Okay, so we'll have to write it then. F of xyz, okay, is equal to, now we have s squared sine of, the expression 2y, okay, minus 5z minus y cos of cz minus 1. Okay, so we need fz, fx, and fy. Okay, so fx is equal to, now I differentiate everything with respect to x. Okay, so fx will be simply, is this 6z? Let me check. Okay, so here, let me check the question. It's 6z. Okay, all right, no problem. So fx will simply be, look through this, where is x? We can find x only in this case. Okay, there's no x here, so all of that part will be equal to 0. Then our fx will be equal to, let me use a different pen, 2x sine of 2y minus 5z. Okay, and then our fy will also be equal to, look through this, where can you find, you can find y here and here. Okay, so with the first part you have to differentiate the bracket and you get 2. Okay, you can differentiate 2y minus 5z with respect to y, you get 2, then you multiply it to the differential of sine. Okay, and that will be cos of 2y minus 5z, then minus, when you differentiate y you get 1, so cos cz. Fz, okay, will be equal to what? Fz will be equal to, let me use another pen. I want to look at the first term here. There's a z here, so we differentiate, you get minus 5 s squared sine of 2y minus 5z. Okay, sorry, differentiate the sign, so here will be cos. Okay, cos of that. Then there's a z here. Okay, so differentiate z, you get 6z, you get 6, but when you differentiate cos you get minus, so you get plus 6y sine 6z. Now our del z del x, we are saying is minus fx over fz, so it's negative 2x sine of, okay, fx is 2s sine of 2y minus 5z all over fz, which is negative 5s squared cos 2y minus 5z, okay, plus 6y sine of cz. Now you can go ahead and simplify this, because I can actually factor negative 1 out from the denominator, and when I do so I'll get this place where I have plus 6y sine cz in the denominator will be changed to a negative, because I'm factoring a negative, and I'll get something like this, so that this negative can take this off. So in case you don't see the previous one and you see this in your answer, that is also correct. Okay, so it can be this or the other way. I hope you get this. Now let's look at del z del y. Okay, let me erase it. Del z del y is actually equals minus fy over fz. And this is equal to, fy was giving us 2s squared cos whatever that we have here, okay? So minus 2s squared, is it that? Let me check. Yes, minus 2s squared cos of 2y minus 5z, okay, minus cos cz all over minus 5s squared cos of 2y minus 5z plus 6y sine 6z, okay. Alright, so with this you can also factor the negative out, or you can, if you want to factor negative out from the denominator, this will come here, the bracket will come here, and when you multiply it will affect, okay. So when I factor negative 1 out, it will be negative out, and here is supposed to be negative as well, okay, so that this will take this off. I hope you get that, and that can also be the answer. So that is it for the solution to the question. Now let's move on to the next question, and I think we'll be done. Solve for dy dx at a point 0, lane 2 for the equation that, okay. So here all that we need to do is simply check if the there is anything at the right side of the equation, okay, because we are supposed to make sure that everything is at the left side of the equation. So here already we have everything on the left side of the equation, so we let f of xy, because there's no z here, equals x e to the y plus sine of xy plus y minus ln 2. Now we said dy dx is equal to minus fx over fy, okay. So all that we need to do is find your fx and fy, given f of xy to be x e to the y plus sine of xy plus y minus ln 2, okay. I hope that is it. All right, now fx will simply be e to the y plus y cos xy, and that is all, okay. Fy will be equal to x e to the y, okay, plus y, no, this should be x rather, s cos xy plus 1. So dy dx is equal to minus e to the y, you said minus fx over fy, okay, so plus y cos xy over s e to the y power plus x cos xy, okay, plus 1. Now the question that we're supposed to answer is evaluate it at 0, lane 2, okay. So we have 0, lane 2 means that wherever you see x, you put 0, and wherever you see y, you put lane 2, okay. So here we'll have, let me simplify them, okay. So if I put lane 2 in y, let me go and simplify them for you, okay. So have dy dx being equal to negative e to the y, okay, plus y cos xy, okay. Let's take our time to simplify it, okay. X e to the y power plus s cos xy. Now we said x equals 0 whilst y is equal to ln of 2. So put everything in, and this will give you minus into e to the power ln 2 means 2 is this e to the power ln 2, okay, and this is the same as e to the log of 2 base e. Since this and this have the same base, the answer is supposed to be this one. Okay, it's a property in logarithm. Okay, so the answer is 2 there, right? And we have plus y is ln 2, so ln 2, then x is 0, so cos of 0 is 1, so we have that over x is 0. I have 0 here, plus here, I think here is plus 1. Okay, there's a plus 1 here, and I have 0, then x times cos, so x is 0, so I have 0 there as well, and plus 1, and I'll have everything to be minus of 2 plus ln 2. Okay, that is the solution to it. Oh, you can see dy dx at the point 0 comma ln 2 is equal to minus 2 minus ln 2. I hope this is okay. Or you can say minus 2 plus ln of half. This can work, okay? I hope you're okay. So thank you, and don't forget to subscribe to my channel, and also stay tuned for the next video. All right, see you next time.